Hi guys, I'm just trying to straighten all this out. That way you can actually see the board and hopefully this looks right for you guys. So we're going to try this. This is going to be our first set of notes. We're going to kind of figure out a way to make this all work as we go along. So physics, we're talking about impulse, okay? So I know you've watched some videos on impulse. I know you know it has something to do with force and time and how that relates. Well, we're going to get some formal notes on that right now. So my first question to you is, would you rather bungee jump with an elastic attached to you or a chain attached to you? And hopefully the answer is an elastic. Why? Because the chain, when you fall all the way down, it will cut you in half, where the elastic will absorb. It's going to absorb that force that as you come all the way down, all that force you're generating by falling with gravity, that elastic will absorb it. And what's it going to do? It's going to allow your body to feel less force than it would if you were attached to a chain. Okay? So the idea I want you to start thinking about is the fact that by having some type of absorption, okay, you will feel less force. And start to think about what absorption does, what that stretchiness does with regard to time. All right. So what is impulse? Impulse can be described by two ways. So the first thing we're going to do is we are going to define an equation for impulse. And we're going to do that by looking at some of our old equations. So F equals ma, you know that one. That's Newton's second law. P equals mv, you know that. That is momentum. And we're going to look at this one, A equals delta V over T, in which we have our, sorry about that. Let me just change the lights. In which we have a change of velocity over time equals acceleration. Hey, this is better for lighting. Who knows? We'll do our best. So we're going to take these two, and we will bring them together to give us F equals m delta V over T, mass times essentially the acceleration, F equals ma still. F equals m delta V. We are just multiplying these out. We're distributing them. Goodness, now the other lights are in the way. What are we to do? We're just going to have to kind of work through it. Apologize about that. And from there, we're going to bring the T over, and we're going to have F times T equals m delta V. F times T equals m delta V. We brought that T right over by multiplying it by both sides. All right, so what exactly is this saying? Well, what it's saying is, okay, just a headshot now. What it's saying is force times time, and we talked about that when we were jumping with the bungee, right? Our force generated by gravity and the absorption, that gives us the amount of time, right? More absorption means more time. Less absorption means less time. Force times time will give us a mass times a change in velocity. All right, so force times time gives us a mass times a change in velocity. And what this is, if we look all the way back to here, mass times velocity, mass times a change in velocity. Take that change out, it's mass times velocity, it's momentum. Put that change back in, it's change in momentum. So this right here is a change in momentum, okay? So we've just pretty much discerned our first equation and exactly what exactly what impulse is. Here's our first big equation, F times T equals m delta V. That right there is our first major equation, and that tells us what impulse is. Impulse is a change in momentum. Impulse is a change in momentum. Right there. Give you a little second to copy that down, and I think this will kick me off in about 10 seconds, so I might have to make another video of this, but hopefully you'll join me in just a couple seconds. Bye for now.